Here, let's look at real number exponents. Our goal is to do three things. 1. Simplify rational expressions containing real number exponents. 2. Describe what exponential functions are. And 3. Solve exponential equations by writing each side of the equation with the same base. First, I'm going to multiply these two numbers together. Now, the square root in the exponent shouldn't worry too much because we can deal with it. Here, since I'm multiplying two numbers together, I'm going to add the exponents. So we get 2 to the 4 minus the square root of 5 plus 1 plus the square root of 5 power. Combining like terms, we get 2 to the 4 plus 1 is 5. Square root of 5 minus the square root of 5 ends up cancelling each other out, so we get 2 to the 5th, and 2 to the 5th is 32. There's our answer. Simple. Here we've got power to a power, so what we're going to do is take 5 to the 2/3, 2 square root of 3, and multiply it by the square root of 3. Well, the square root of 3 times the square root of 3 is 3, so we've got 5 to the 2 times 3 power, which is 5 to the 6th power. 5 to the 6th power, if you're wondering, is 15,625. There becomes our simplified form. Now we've got division problem. If we divide, we subtract the exponents. 3 to the 2 plus the square root of 7 minus 2 minus the square root of 7. Now, I've got to remember to distribute the negative, so we get 3 to the 2 plus the square root of 7 minus 2 plus the square root of 7. This time the 2 cancel out, and the square root of 7 plus the square root of 7 is 2 square root of 7. So we can write it as 3 to the 2 square root of 7. Or, we can square the 3 and make it 9 to the square root of 7 power. The difference between exponential functions and all the other functions we've been looking at is that my variable is now in my exponent. So I could have things like y equals 2 to the x power, or y equals 376 to the x plus 2 power. This would also be an exponential function because my variable's in the exponent. So solving these types of problems, well, what we want to do is get both sides into the same base. In this case, I'm looking at a base of 2 because 4 here and the 1/2 here I can rewrite as powers of 2. For example, 4 is 2 squared. So this is really 2 squared to the 2x power. 1/2 is 2 to the negative first power. Because if I had 2 to the negative first, I'd rewrite it as 1/2. So it's 2 to the negative first to the 1 minus 2x power. Now I'll simplify these. We got 2 to the 4x power equals 2 to the 2x minus 1 power. Now from here, since the bases are the same, it means the exponents really should be the same. So that's what I'm going to do. 4x equals 2x minus 1. They really should be the same for this to work. If that's the case, subtracting the 2x, we get 2x equals negative 1, or x equals negative 1/2. So for this to work, x needs to equal negative 1/2. Looking at this case, my base is not going to be 2 this time because I can't rewrite 5 as 2, and I can't write 1/25 as anything 2 to anything power, but I can work with 5. So 5 to the 3x power. 1/25 I can rewrite as, well, 25 is 5 squared, and it's in the denominator, so it's 5 to the negative 2. And that's all to the x minus 1 power. I'm going to simplify that again, so 5 to the 3x equals 5 to the negative 2x plus 2 power. Bases are the same, set the exponents equal. 3x equals negative 2x plus 2. Add the 2x. 5x equals 2. So x must equal 2/5. So for this expression to work, up here, x must be 2/5 every time it shows up in the equation.